Tuesday, January 7th, year of our Lord, 2020. All right. Yesterday, we worked through 2, 3, and 4. We cleared those problems of decimals, ladies, by multiplying by either 10 or 100, right? Today, at the bottom of 283, 5, 6, and 7, we're going to eliminate fractions by multiplying by the lowest common multiple, which in number 5, that number is 10. So we got 4/5 x plus 3 equals negative 7/10. And we're saying if we multiply everything here by 10, what would this look like? What would 4/5 look like multiplied by 10? If I multiply everything by 10, what's my new problem look like? And it's still the same problem. Because listen, I'm increasing everything, listen to this word, proportionally, therefore everything still stays balanced and equal. Does that make sense? You understand that word proportionally? Everything's being increased by the same amount, so the problem still stays balanced and equal. Does that make sense to everyone? Okay, so if I multiply everything by 10, how many x do I have? 8x, because what's 10 times 4/5? What is 10 times 4/5? 1, 2, it's 8. So my new problem is 8x plus, what's 3 times 10? 30 equals, what's negative 7/10 times 10? Negative 7. And now, look. Now, I'm going to work with all whole numbers. Does that make sense? Okay, so now I do my algebra. What do? I got to find out, down here, I want to know what x is. How do I get rid of the things that are attached to the x? First, let's get rid of the positive 30 by subtracting 30. What am I going to write? 8x equals negative 37. How do I get rid of the 8? Divide. Negative 37 divided by 8. You should be able to do that in your head by now. 4 and how many? 5/8. Is it negative or positive? Negative 4 and 5/8. Let's ponder this a moment and make sure you understand everything I did. There are several students every day, every week that goes by, and how do I know this? Because we take tests and quizzes. So every day, every week that goes by, there are several students that sit out in the gallery out there, and they don't understand what's going on, and their teacher says, hey, the only stupid question is the one that wasn't asked. And the teacher stops all the time and says, does everybody understand? I'll stop and go slow. I'll do the whole thing again. It doesn't matter to me. And they don't ask. And then the test comes. And I'm thinking, why didn't they ask? Pride. Did you really have a question, Lauren?
No.
All right. Anyone? Why did I do this? Listen, I could have solved this problem and had to deal with fractions. But why? Why not just do something simple like multiply, make them all whole numbers? I would have got the same answer if I would have just worked with fractions. Make sense? Let's try number 6. 2s. I don't like when they use s. You know what? I'm going to write an x.
Exactly like 5.
Right. 2x minus 1 1/4 x. I'm being defiant. Equals 1/3. I'm refusing to use the s and have it look like a 5. Okay. How can I get rid of all the fractions in this problem to make it nice and easy to work with whole numbers. I have to listen, in order for this to be mathematically okay to do, I have to multiply everything by the same value. Everything has to increase proportionally the same in order for everything to stay balanced and equal. So what am I going to multiply everything by, Seth? What do you think? If I multiplied everything by 4, that wouldn't help me. Because what would this be? 4/3, still a fraction. Who said 12? 12! Because multiplying by 12, that's the lowest common multiple. That way I know I'm going to rid everything of fractions. Does that make sense? You know what I might do first? Who has a clue what I might do with this guy first? Before I multiplied by 12, I might do something with this mixed number.
Change it into an improper.
Yeah. Right? Doesn't that make sense? Because even the multiplying 12 times 1 1/4 is so much easier to multiply 12 times 5/4. You know what I mean? You getting that, Noah? You picking up what I'm laying down? If I multiply everything out here by 12, I get 24x minus 15x equals 4. Now, no one's going to raise their hand, and I'm going to say, does everybody understand how I got from one line to the other? And there's at least 4 people that don't understand, and no one's going to raise their hand. Go ahead.
How'd you get the 15?
All right, I got the 15x because either I go like this, 12 over 1 times 1 1/4. Well, eventually I'm going to change it to 5/4, right? And I go, whoop, whoop, 15. Because 1 1/4 is 5/4, so 12 times 5/4 is 15. Good question. Does everybody understand how we got 4 out here? 12/3 is 4. Now I've got a nice, tidy problem here. Look, like terms, can I combine them? Yes. 24 minus 15 equals, how do I get rid of the 9?
You just divide it by 7.
4/9. Any questions?
No.
All right, Noel, thank you.
Oh wait, never mind. I just figured it out in my head.
Okay. Yes.
Never mind.
So much for the question.
I just remembered.
Okay. All right, number 7. What are we going to multiply everything by in number 7, Casey? I've got denominators of 6 and 8. Well, I could multiply everything by 48, and that would be okay, except it would make everything bigger than it needs to be. I want to multiply by the least common multiple. Right? By multiplying by the least, I make it a little simpler. Trying to think, but nothing happens. Dominic, 24. Case, right? 8, 16, 24, 6, 12, 18, 24. So I'm going to multiply everything in number 7 by 24. Why don't you do that? This time, as I'm erasing, you start the problem and see if you do what I do. You get what I get. Where you go, I will go. And your problem will be my problem. A few people got that. 5, 6V plus 5 8s.
I don't like B.
I kind of like them. You know why I like V? Because it stands for
Because I don't like it.
victory. And I like victory.
Yeah. That's not hard.
Although no, that's a different subject. 5, 6V, 5 eighths, 3 eighths. I'm going to multiply everything by 24, says Casey, via Dominic. At least one hand has to go up, unless you're all incredible geniuses already, to understand how I got from the brown to the blue.
I did not do that
No.
at all.
No. 20?
Lauren!
How did you get 20?
Yeah.
How do I get 20V?
Yeah.
Because if I take 24, did you agree that we're going to multiply everything by 24?
Yeah.
Okay, so if 24 is going to clear it, 24 over 1 times 5, 6, 4 times 5.
Oh.
Oh, that's how you do it.
Because you can't multiply fractions unless you have 2.
Fractions.
So I put 24 over 1 and I cross cancel and boom.
Okay. That makes sense. Now.
Case, get it? Evelyn? Shh, question, Noah.
How'd you get 15?
Okay, 24 over 1 times 5 eighths. Cross cancel, 3 times 5.
Did you get the same, did you do the same process for that?
For this,
Yeah.
Yeah. 24 over 1 times 3 eighths. 3 times 3. I got 9V.
That's what I got.
Combine like terms. Do you want to take this V term and put it on the right? Or do you want to take this V term and put it on the left? Decision has to be made now. Most of the time, we're more comfortable with the variable. We want to like X equals, the variable is usually on the left, right? Sometimes it's more convenient to put it on the right because we want to work with positive numbers. In this case, it's true for both. If I move it to the left, it's going to stay positive. Does everybody see that? Look, before I combine my V terms, Noel, I do have a choice. I can move this V to the right of the equal sign or this V to the left of it. It makes total sense to move this V over to the left because 20 minus 9 is going to give me positive 11.
But then you get 29 plus 15 equals.
0. And we'll deal with that. Watch. If I subtract 9V over here, that leaves me with nothing. That's okay, because if I subtract 9V here, I got 11V plus 15 equals 0. Don't be afraid of that, because now how am I going to get rid of the 15? I'm going to subtract 15 from both sides. $11V equals negative 15. How do I get rid of the 11?
How did you get 11?
I got 11 because 20 minus I divide by 11. I got V equals negative 15 over 11 or negative 1 and 4/11. Questions, Brett?
How did the 15 become negative?
The 15 became negative because in order to get rid of this positive 15, I had to subtract 15 from both sides. So 0 minus 15, negative 15. Okay, you're either the sharpest, quickest learning pre-algebra class ever, or you're still not asking stuff you don't understand.
Let's see if those are both easy with the questions.
David,
So, we do, 11,
here,
I mean, no, 20 plus 15 plus 9B, 20B plus 15.
remember 20B plus 15, I can't combine these two. They're not like terms.
What do you, so you don't subtract first? You don't do the 15 first? You add the like term first?
It didn't matter. Look, what, everybody understand, at least what David's saying is, if I would have gotten rid of this 15 first, this would have been 9B minus 15, and then I would have brought the B's together, I would still end up with 11B equals negative 15. So David, you could do it that way first. You're still going to be right here. 11B equals negative 15. Yes?
I thought you combine the like terms and you would get 29. That's what I didn't know.
Yeah, but when I combine them, I can't subtract 9B from here and add it over there. That messes up the equality. Remember, on both sides of the equal sign, you have to do the same thing in order for it to stay equal. So if I had to get rid of B on one side or the other, right? I want to know at the end what B is. So to get rid of this B, I had to subtract 9B. So I got to subtract it. David,
If it was negative 9B, would you add?
if this was a negative 9B out here, how would I get rid of negative 9B? I'd add 9B. Turn the page. Now we're just getting ready to what would be your homework, and you've got how many minutes left? 9 through 22. 9 through 22. Go. Scooby-Doo.
Scooby-Doo.
You ever watch it?
Yes, Sarah has the whole thing.
Cereal?
Sarah!
No, are you cereal? Well, it is 68, so most people think that's a little chilly. I've gone to wearing something heavy every day this year, so I don't notice it.
I'm freezing. Right now. I don't know why, but I am. Like, Mrs. Reed's I don't really know.
All right, no questions yet.
I'm sorry.
What are we gonna do first in number 9? Spencer wasn't here yesterday. Isaac, tell the rest of the class, especially Spencer's because he wasn't here, what you're gonna multiply everything in number 9 by to clear it of decimals so you can just work with whole numbers.
10.
You're gonna multiply everything by 10, Spence, because that gets rid of all the decimals. Because 8.2 times 10 makes it just 82.
So you can multiply by 10 no matter what.
Everything by 10. Because, Spence, because the most decimal places you have is 1. 9 through 22.
So then would it be 40R?
Hold on. It's going to be 10R plus 82 plus 4R, because you're only timesing it by 10, 4R equals. Of course I will, Sydney.
Can you limit it to 9 to 16? Or 9 to 5? 9 to 5. It's just 9?
All right, Lady Chatterley, listen up. So I just went through the problems on the previous page, and I would stop and say any questions, right? And now you're like, okay, go ahead, do your homework. And you're afraid. Just go. I got to let go of the bite. All right, here we go. Number 9. R plus 8.2 plus Alright, there's way too much chatter when over half the class has not done number 9 yet because you're waiting for me to do it to make sure you know how to do it. So I don't know what all the extra chatter is about. We already established we're going to multiply everything by 10. Right, Ethan? Because, look, the most decimal places we have is 1/10. So by multiplying by 10, we get rid of all the decimals. Now, I can't just pick and choose which things I'm going to multiply by 10. That messes up the whole balance of the problem. Everything's got to be multiplied by the same number in order for it to stay equal. So I've got 10R plus 82 plus 4R equals negative 86. If you don't understand how I got from brown to orange, raise your hand and we'll go through it again. This got rid of all decimals. And now I'm working with whole numbers, easier to work with. What's the next thing I'm going to do? Not yet.
Gonna combine the.
Combine like terms. Next thing I'm going to do is combine like terms. I've got 2R terms here. That gives me 14R plus 82 equals negative 86. I'm not skipping any steps here. Once you got more experience, I probably would have done the next 2 steps. I probably would have done it in 1 step. But I'm going to take my positive 82 and get rid of it by subtracting it from both sides. That leaves me with 14R equaling negative 168. How do I get rid of the 14? Divide both sides by 14. And they made it nice and crisp and clean for you. Because 168 divided by 14 is 12. Negative 12.
I got 28. I got that. I was way off. I don't know how I got it.
Me either. I'm trying to figure out a way that you could have.
Okay, now that I got that.
Okay, Jaden.
And you need number 11.
Not number 10? No.
Your face was.
All right, number 10, you would have multiplied everything by 10. Number 11, you're going to multiply everything by 10. All right, ladies and gentlemen, I'm going to do number 11 on the board, but I'm not going to write the original problem. I'm going to write it, because for time's sake, I'm going to write number 11 as if I already multiplied everything by 10. So here's what 11 is going to look like once you clear it of decimals. 53 plus 10U equals 32U minus 27. Does everybody understand that? We're on number 11. I multiplied everything there by 10. This was 5.3. This was 3.2U, and this was negative 2.7. Everything's multiplied by 10. Decimals are gone. The next thing I do is I combine like terms. I've got U terms on both sides of the equal sign. Decision time. Am I more comfortable with, hey, I like to have my variables always on the left? Or am I more comfortable with, hey, I always want to work with positive numbers. Because it doesn't matter which side the variable's on. Spencer, is there a difference in these two things I just wrote? X equals 6 and 6 equals X?
No.
No, they're the same thing. So it doesn't matter which side the variable's on, the letter. So since I like working with positive numbers, Jaden, I'm going to choose to put my U's on the right. Because I notice that if I subtract 10U, that's going to give me a positive number on the right. You with me? Ladies and gentlemen, Isaac, do you realize I could take 32U and subtract it from both sides? And I would still get the same answer. You with me? But I'm going to subtract 10U because that's going to keep my U's positive. Got it? Okay. So minus 10U. I've got 53 equals negative, I'm sorry, the whole point was positive, 22U minus 27. We've got to add 27 to both sides. You see why?
Yeah.
Got to divide both sides by 22. Oh, they're going to give me the answer. Sure. Bella? 3 and 7. Okay. Listen. What was the original problem given in? Fractions or decimals? So the rule in math is if they give you a problem in fractions, they want the answer in fractions. If they give you a problem in decimals, they want the answer in decimals. So we're supposed to give them the answer in decimal. So if I do divide by 22, U equals 80 divided by 22. I want to see who's math-minded and understands why I did what I'm about to do. Ready? Raise your hand if you understand why I did that. 80 divided by 22, I wrote over here 40 divided by 11.
Oh.
I want you to make sense of that. Do you get it, LP? Because I have to divide these two, and I'm just making them smaller. What did I do? I reduced it to 40 over 11. Do you see what I did, Elise? Listen, if you can't understand that, that's okay. Just do 80 divided by 22. You're going to get the same answer. So I get 3. I can NX zeros all day long if I need to. 6. 3. Uh-oh, I see a pattern developing. 6. It's going to be 3. So what's going to keep repeating? The 6 and the 3. Well, how do I fix that? I put a line over both the 6 and the 3. Who would have thunk just 2 years ago that you'd be sitting out there and being able to do stuff like this? Remember 5th grade math?
And we hated division. It was the worst thing ever.
And here you are if you're in 7th grade. 2 years later, you're like doing this stuff. It's pretty awesome. Because when you guys leave and the 5th graders come in, they look at the board and they're like, it's like,
You said think
incredible.
No. You said
It's actually not that hard.
I said, what?
You said think wrong. You said no.
Who would have thunk? Yeah.
I'm pretty sure it was intentional.
We're never gonna get done.
Do you really think I think that it's
Is it 322?
correct grammar?
It said you're right.
9 through 22.
Oh, that was just 11.
Oh,
I
man.
still have 10 more left. I'm not gonna get it done.
Go.
I have practice after school, and then I have.
Okay, so you're sitting there doing nothing.
Yeah, I know. 'Cause it's not good.
By the way, this
And
is
then I
on
have-
video,
I know.
so I just tell Mrs. Reynolds, go to YouTube.
Hi, Johnny.
You'll hear the conversation between your daughter and I while she sat there wasting time.
And then I have to basketball games. I'm probably gonna get home at like 10.
So get it done.
Johnny doesn't do his homework.
Come on, Jojo.
Who's it done the sky one and I like one?
Casey, shh. What are you gonna multiply everything in number 12 by? 100, Spencer. Everything in number 12 is going to be multiplied by 100. Why, Spencer? Because 4.93, Spencer, times 100, whoop, whoop, 493. Do you see how that makes it a whole number? 9.20, whoop, whoop, multiplied by 100, 920. 0.66, whoop, whoop, times 100, 66. Do you see how that works? So everything's got to be multiplied by 100 in number 12. Number 13, everything's going to be multiplied by 9. Number 14, everything's going to be multiplied by 10. Number 15, everything's going to be multiplied by 6. Number 16, everything's going to be multiplied by 12. Number Zacchaeus.
Is that right?
Cheers. Where do you play tonight?
I don't play. Luke is like, and then we have to stake the varsity 85.
Better be this way. You went to the chain. Varsity.
Did they lose?
JV.
We beat the only one and we lost them the first time. There's a really mean girl on that team. She kicked great.